Hi, welcome to MACSGATE. We are learning DBMS subject. Under DBMS subject, in today's session, we are going to start SQL, Structured Query Language. And in this session, we are going to discuss the basic syntax of SQL. Let us start the session. SQL, Structured Query Language. The commands of SQL are mainly classified into the following types. DDL, Data Definition Language. Data Definition Language. This is mainly used to create the tables or to modify the structure of the tables. That is, the commands which deals with the schema of the relation are in this group. The next one is data modification language or data manipulation language. Either modification or modification. Okay. The commands which we use to change or to update the database, that is to update the data in the relation, that comes under category of DML. The next one is DRL, data retrieval language. Data retrieval language. The commands which we use to get the information from the database. Under this part, we don't modify anything in the database. Just we try to get some information, depends on our requirement. This is our main concentration with respect to our GATE exam point of view. The remaining commands also we discuss, sir, but we don't go in depth. The next one is data control language. Data control language. These commands we use to give permissions and to revoke permissions to different users depending on their roles in the database. The next one is transaction control language. Transaction control language. Something like what to be saved or to which point I need to roll back. Like that, all those commands we will discuss under this category. So these are the 5 types of DDL SQL commands. Fine. So let us discuss each of these one by one. The first one is DDL, data definition language. What are the main commands we are having under DDL, or what are the tasks we can complete under DDL? Let us see. The first one is create, creation of a relation or creation of a view, creation of a index. Alter, whenever I have a relation schema or I have a relation, sometimes I want to change the structure of the relation. For that we use this command. Then rename, to rename the relations, to rename the columns, we use it. Drop, drop is in general English delete. If I want to delete a relation completely, then we go for drop. Similarly, truncate, truncate also will delete the data in the relation. The main difference between drop and truncate, sir, both will delete the entire data in the relation. When coming to drop, it will delete the schema also. When coming to truncate, it don't touch the schema. That means to delete the entire data in a single shot, I can use any one of them. If I want to delete relation also, then we go for drop. If I want the relation to be in the database, then we go for truncate. The next one is comment. Comments mainly provide what we are going to do in our code. So this is the main categories of DDL, data definition language. Let us discuss each of these one by one. And in this session, we mainly focus on DDL part only. In next session, we will discuss DRL. So coming to DDL, create. How to create a table or how to create a relation. Before going to creation, if I want to create a relation, I need to specify what are the attributes. Whenever you are specifying the attributes, Compulsorily, we need to specify the data type or the domain. Generally, we call that as domains, are the domain from which we can consider the values for that particular attribute. That we should know. Now the question is, what are the keywords to specify the particular domains? Sir, the main set of domains we use integers, right? The first one is integers. The second one is real numbers. First one is integers, the second one is real numbers, and the third one is strings. These are the three frequently used domains in our programming life, right? Now, what are the keywords to represent these integers, real numbers, strings? When coming to integer, generally people will write simply integer only, and in the parenthesis we specify 5. What does it mean? Maximum it can hold a 5-digit integer. Instead of this one, we can write number. So depending on the SQL software, either integer or numbers are, that depends on, okay, maximum 5 digits we can write it. When coming to real numbers, number of, suppose I have written 7,2. What does it mean? Totally I am having 5 places. Out of 5 places, 2 places are after decimal. 2 places are after decimal. That is about real numbers. Then coming to strings, we can use char of 20, not only 20, sir, you can use any length. What is the meaning of char of 20? I can store a string of maximum length 20. That is 20 characters. Instead of char of 20, you can have varchar2 of 20. So depending on the question, you can understand what their intention, whether it is an integer, number or string. Most probably we follow the keywords number and varchar2, right? So these are the data types we should know at least to start our commands in DDL. Now let us start it. I want to create a relation. Suppose this is the relation I want to create. Then how to create it? First of all, I should know the name of the relation. Here, the name of the relation we are going to create is employee. So create table. Create table. What is the name of your table, sir? Employee. Create table employee. Then what are the attributes? Employee ID, right? First, let me list out all the attributes. Employee ID, name, age, department, salary, right? Suppose employee ID is a integer, sir. Employee ID is a integer which is having maximum 3 digits. That means I can have 101, 209 or some 521 like that. So maximum of 3 digits in my integer. Then when coming to name, let us assume it can have maximum of 20 characters. Then we write it. For every attribute we need to separate by comma. Then coming to age, so either integer or number, that we can write, sir. Okay, so let us suppose the age is also maximum of this one. When coming to department, it is a string, sir. Okay, since we already used char, let us use varchar2. Sir, when you are working with database, okay, only some of the keywords will work depending on the software you are using. Okay, that may be integer or that may be number, right? So let us assume department is of maximum 3 characters. What about salary, sir? Suppose salary is a real number which can have a maximum of 10 places. After decimal, we are having 2 places. So this is the way we need to create the table. First, we need to decide what is the table name or relation name. Then what are the attributes and what are the domains. Depending on the domains, we need to choose the appropriate keyword to specify it. So that is about the creation of the table. Hope you understood it. Then what are the constraints we need to consider when we are creating relations in database? Okay, the constraints are unique, not null, check, default, primary key, foreign key. So these are the constraints we can specify when we create a relation. Previously or in the last slide, when we are creating a table, we not specified any condition. That means the user can enter any value. For example, suppose age. Suppose you given age number of 3. That means user can enter maximum of 3 digits. Suppose he enter 924. Maximum 3 digits, right? So our table will accept that value. Now the question is it possible to have a age of 924, sir? No. So compulsorily when we are creating a table, it is better to specify some constraints. So these are the different types of constraints we are having. Let us discuss each of them one by one. Coming to the first one, unique. What is meant by unique? For the particular attribute, all the records should have distinct values. All the records should have distinct values. This is the table we have created, sir. Suppose, let us suppose that I want the name should be unique. The name should be unique among the employees, or the employee ID should be unique. Okay, I think better to have employee ID, right? You can have anyone, sir, no issue. Okay, suppose this is my requirement. Then instead of specifying simply EID of number of 2, what I do is employee ID number of 2. At the end, you specify unique, comma. That's it. Like that, for any attribute you can specify, sir. Sir, that is our relation, our database. We can specify constraint on anyone. Suppose I want this department should be unique. That's the same story. What I do is department varchar 2 of 5. At the end, we need to write unique. That's it. Then if there is already a record with the CSC department, and if I am trying to insert one more record with the CSC department, it will not accept, because all the records should have distinct values for that particular attribute. So let's go to the next one, not null. Not null. Suppose every employee must enter their salary. Something like when we are filling an application, for some fields we are having star mark. That means they are mandatory. The user should not leave it as a blank, right? That is not null. So when you specify any attribute as not null, then user must fill it. Otherwise, it will not be accepted to insert the record in the table. Suppose this one I want to make it as not null. Then the same salary, sir, salary number of 10, 2. At the end, I specify not null. At the end, we specify not null. Clear, sir? Then let's go to the next one, check. Okay, check can be used to verify the values for that particular attribute. Suppose age, generally the age can be 0 to maximum of, can I assume 150? Yeah, maximum of 150 age, right? Okay, so even it is allowed to enter 3 digits, but the maximum limit for the age is 150. Then in such case, what we do is age number of 3. Here we write check age less than or equal to 150. If age less than or equal to 150, it will accept that particular record. If it is not, then it will not accept. Suppose in our college we are having only the departments CSC, ECE, triple. We are having only 3 departments. Then surely every employee of our institute should enter only any one of these 3 values. Then in such case, what we do is check department in CSE, ECE, triple. So if the employee enters any other department except these 3, it will not be allowed. Hope you understood it. Then the next one is default value. By the name, it says that whenever the user not enters a value, then what is the default value? Okay, let us suppose the user is not entering the age. Okay, let us assume the default age, or we are assuming the average age is 30. So whenever he don't enter any age, I will take 30. So whenever you want to do this one, I will do like this. Name, number of 30. Okay. Sorry, number of 3, default is 30. So then if he enters, it will consider that particular value. If he don't enters, then the default value will be 30. Now the main stories are main heroes, primary key and foreign key. These are the 2 main heroes, sir. What is primary key, sir? We have so many times seen. Okay, it need to satisfy 2 constraints. First of all, it must be unique. The second one is it must be not null. Okay, or any one of the candidate keys we will designate as a primary key. Suppose employee ID, I want to make it as a primary key. Then what should I do? So employee ID number of 2. At the end, we write primary key. Or instead of that one, in the last line, we can specify primary key of employee ID. Whenever you specify it is a primary key, surely it will satisfy the constraint unique and not null, because according to the definition of primary key, it should be unique and not null. It should be unique and not null. Hope you understood it, right? Then what about foreign key, sir? Sir, foreign key is mainly related with 2 tables. Mainly related with 2 tables, right? Suppose I am having 2 tables like this. Okay, department and employee. What my assumption is, department is the table in which department name is primary key. So this is my primary key. This primary key I am using as foreign key in employee table. And employee table may have some primary keys, sir. So this is its primary key. Okay. So whenever you want to specify the foreign key, okay, compulsorily it must be a primary key in another table. If the attribute is not a primary key in one table, then I cannot use it as a foreign key, right? Now, first let us define the first table, department. Create table, department, right? So let me write it, sir. Department. What are the attributes you are having, sir? The first one is dname. The next one is head of the department. The next one is block in which the department. Let us assume department name is a string which can have maximum of 5 characters. Okay, and department name is a primary key, sir. You can specify at the end or you can specify at the beginning. That depends on you. Okay, let us specify at the end. Okay, let us assume HOD. It is also a string. So varchar 2 of maximum, let us suppose some 20 characters. Then block number. Okay, that may be integer or that depends on. Okay, let us assume it is a number. Okay, that's it. Now I want to specify the first one, primary key. Primary key of department name. So this is the way we need to create a table with primary key. Now I want to specify the second table with the foreign key also. Okay, let us consider it. Create table. Let me write like this, sir. Create table employee. Okay, what are the names, sir? Let me have it. EID, name, age, department, salary. Sir, we already specified the attributes. Okay, for now, let us specify. Employee ID is a number of 2. Name is a varchar 2 or char, that depends on, sir. You can write anyone. Okay, age, it's a number. Number of, suppose it is 3. Now look at this, sir. Sir, this department we are supposed to specify as a foreign key. Then the main thing is whatever the data type I have, better to have the same data type. So varchar 2 of 5. At least instead of 5, I can have 6 or 7, but I should not have 4, sir. That means here I should not have 4, because suppose there is a department like with 5 characters. How can I store that value in this, sir, if it is having maximum 4 characters? So that's why better to have same data type. At least it should be sufficient to hold the values of the original values. So let me write 5. Instead of 5, you can write 6 also, no issue. I need to have sufficient width to hold the original values. So let us don't take any risk. So let us specify the same. Then let us consider number. Salary maximum of 10,2. For this, what is the primary key, sir? We are assuming employee ID is the primary key. Okay, let me write it here. The last one, sir, what is that, sir? Foreign key I want to specify. Foreign key of department. Sir, please observe it. The foreign key may not have the same name as the primary key. That depends on your requirement. You can have dname or you can have something else also. There is no rule that foreign key should have the same name as the primary key. Okay, So department is a foreign key which references, that is I need to specify the table name which references. What is the table name, sir? Department. In department, what is the column name of that one, sir? That is D name. So department is a foreign key that refers to the D name of the department table. When you are discussing that constraints, relational constraints, I told you on delete, cascade, on delete, set null value, like that, right? So you can specify here on delete, cascade. That depends on our requirements, sir. You can specify on delete, cascade, on delete, set null, on delete, so on so, or update, we can specify it. So that is about the creation of a relation. When we are creating a relation, you can specify the constraints like unique, not null, check, default, primary key, foreign key. Hope you understood it. If you have any doubts, please raise in chat box. So then let's go to the next one, DDL, alter. Sir, this is mainly to change the structure of the schema. Table is already there. This is the structure, right? This is the schema or skeleton or structure. That means we are not considering the data, sir. Of course, in DDL, we don't consider the data in the table. We consider only the headings or the attribute names only. So, structure or schema or skeleton. Whenever I want to modify it, I will use alter. Alteration. Then the question is what you want to modify. Whether you want to change the table name, you want to change the column name, you want to add the column, you want to delete the column. There are so many possibilities. What are the possibilities? These are the 4 possibilities we are having, sir. Of course, you may have some other possibilities. These are the frequently used possibilities to alter the structure of the table. Adding a column. For this employee, I may want to add one more extra column. Removing a column. I don't want that age. I want to remove it. Modifying a column. That is, sometimes I want to change the data type. Something like, suppose for salary, previously I given a maximum of 10 digits. Now I given increment to all of my employees. The salary crossed 10 digits. Then I may want to change the data type. 15 digits or 16 digits. Renaming a column. Instead of name, I suppose that you can have ename, employee name. So I want to change the name of the existing column. So these are the frequently used alterations for relations. Let us discuss one by one. Coming to the first one, adding a column. Suppose for this table, I want to add one column. For example, what we can have, sir? Mail. I want to know the mail ID of the employees. Then the question is alter. That is a keyword, sir. Table. That is also a keyword. What is the table name you are having, sir? The table name is employee. Alter table employee. Fine. You are going to alter the table. Then what you want to do? That you need to specify here. Add column name. What is the column name, sir? That is mail. What is the data type of the mail ID? Suppose it is a string. It is a string, maximum of 20 characters. That's it. Right? So alter table name, add column name, data type. That's it. So that is, we want to add it. Even you can add 2 columns at the same time. Suppose I have one more mobile number. I think better to write like this, sir. Okay. Then the same thing you can do, sir. Add. I want to add two things at a time. Mail varchar2 of 20, comma, the next one is mobile number. And let us assume it is a integer or number which can have maximum of 10 digits. Right, sir? So this is the way to add the columns to the existing relation. So we are altering the table structure. Hope you understood it. Removing a column. Suppose I don't want age. I don't want age. Alter table. What is the table name, sir? Employee. Okay. What you want to do, sir? You want to drop one column or you want to delete. So drop is the keyword, sir. Drop column. What is the column name, sir? Age. Alter table name, drop column name. So this is the way we can remove a column from the existing relation. Modifying a column. Whenever I want to change the data type, sir, modifying a column, what are the two possibilities? Either you modify the column name or you modify the data type. Whenever you modify the column name, that we discuss as rename. Whenever you want to modify the data type, we will discuss here. So that is alter table name. What is the table name, sir? Employee. Modify. What you want to modify, sir? Suppose the salary, I want to increase the data type size to 15 of 2, that is number of 2. Maximum it can have 15 digits. So modify salary. Number of 15 comma 2. So this is the way we can change the data type of the column. Then how to rename a column? Suppose I want to change the name as employee name or e-name. Sir, you can give any name, sir. Okay. So alter table name. Then what is the keyword, sir? Rename. Rename. Column. What is the old table name, sir? I think column is a keyword, right? So let us write with yellow color. Rename, column name, name. to ename. Right? Sir, depending on the software you are using, that may be Oracle or MySQL or DB2, there may be small deviation from the syntax, sir. Something like sometimes you may need to specify the keyword column. Sometimes it may not be needed to specify the column keyword. That is rename, name to rename. So that depends on the software you are using, sir. But I am giving the general structure. Okay. So this is how we can alter the structure of a relation. There may be small deviations, sir, some 20% deviation depending on the software you are using for all these commands. Okay. Please make sure that you understood that. Then let us go to rename. The third one, sir, rename. Sir, whenever you want to rename, there are only two possibilities. Either you want to rename a table or you want to rename a view. Okay. So whenever you want to rename a column, that we have already seen, sir. Just now we have discussed. Alter table name, or you want to write it alter table employee, rename column name to ename. So that is the way we need to rename a column. Suppose I want to rename a table, something like this is employee. Now I want to give as, instead of employee, I want to write simply M. Right? So then rename is the keyword, sir. What is the old table name? The old table name is employee. To what is the new table name? Sir, new table name, no need to give M. You can give something else also. Okay, you can give Sudhakar also. That's it. That is the way we can rename the columns or relations. Then how to delete a table or how to delete a column. For deletion of a column, we have just now seen, right? Alter table name, drop column name. Suppose we are dropping the column age. Then we do it. Suppose I want to delete a relation, deleting a table or relation. When you delete a relation, the data will be also lost, sir. So of course, when our relation is not there, how can I have data, sir? It's not possible, right? So drop table or view. If it is a view, we will write view, sir. So drop table. What is the table name, sir? Employee. Right? Drop table employee. So this is the way we can delete the columns as well as the relations. Then truncate. Sir, the same truncate or drop, both are same, sir. Truncate table name. That's it. Now, what is the main difference between truncate and drop? Difference between truncate and drop. Sir, when you drop schema as well as data, both will be deleted. That is, structure as well as data, both will be deleted. But when you truncate, schema will not be deleted, sir. Only data will be deleted, but the entire data. Schema will not be deleted. That means the table will be there, only the data will be deleted. This is the main difference between drop and truncate. Both are DDL commands, both can be used to delete the entire data, but drop will delete the table structure also. That is, table completely vanished. But when coming to truncate, data will be lost, table will be there. Okay. Then comment. Most probably in comment, what you are having, sir? Either it can be a single line comment or multi-line. For single line, we use two hyphens, sir. Like this is DDL session. For multi-line, it is equal to our C programming, sir. This is similar to C language. Right? So this is about the comment, sir. Right? So this is about DDL, that is which deals with the structure of the table. Then coming to DML, data manipulation or data modification. That is, suppose I want to insert a Sita like this. This is data, sir. Something like I want to insert a data or insert a record. I want to delete a record. Suppose Sita left our institute. Then I want to delete Sita. Sometimes I want to update. Suppose we give an increment to Sita. Then I want to update. So mostly these are the three actions we do in DML. Insert, delete, update. How to insert a record, how to delete a record, how to update a record. That's it. Right? So let us discuss each of these one by one. Okay. Suppose I want to insert a record. Right? Let us assume I want to insert some Sita is already there, right? Let us assume I want to insert Suma. Okay. Let us assume our employee ID is 27. So 8 is 20. Let us assume she is in CSC department. Our salary is 4,000. Then what should I do? The command for insert is insert into table name. Insert into both are keywords, sir. What is the table name? Employee. Then what you are inserting, sir? You are inserting some values. So values. What are the values you are having, sir? 77 is a number. So you write it. Soma is a string enclosed in quotes. 20 is a number. CSC is a department. Then 4,000. So this is the way we can insert a record. Suppose I have one more employee, Rita. Okay. She don't want to specify the age. And she joined in AAA department. And her salary is 2,500. So we are inserting only some of the values. We are inserting only some of the values. Then in such case, insert into employee, but this time you are specifying only some of the attributes. So you need to specify the attribute names. ID you are specifying, sir. Name you are specifying. Age you are not specifying, so leave it. Department, salary. So these are the attributes you are going to specify the values. Values. What are the values, sir? 88 Rita, she is in triple department and the salary is 2500. Right? So this is the way how we can insert the records in the table. The next one is I want to delete the table. Sorry, it's not delete the table, sir. We are deleting the data because we have already seen how to delete the table. Now let us see how to delete a record. Suppose I want to delete Sita record. I don't want this fellow. Delete is a keyword, sir. From is a keyword. What is the table name, sir? Employee. Whom you want to delete, sir? You want to delete Sita. So whenever you want to delete a particular employee, you know at least one property or one detail of that particular employee. So you need to specify whom you want to delete. Where, what you know about that particular employee, sir? I know name. So where name equal to Sita. Name equal to Sita. Suppose there is one more employee with Sita, then she will be also deleted. So most probably whenever you want to delete a particular record, better to specify the record based on the primary key, because there will be only one employee with the specified primary key value. But if we specify something else which is not primary key, there is a possibility that other records also will be deleted, right? Okay, now the second possibility is here you specified it. Suppose you written like this: delete from employee. Delete from employee. You not given any details. You not given any details. What will happen, sir? All the records will be deleted. All records will be deleted. But it don't touch the structure, sir, because DML don't have any connection with the structure. DML don't have any connection with the structure. So all the records will be deleted because you not specified on what basis I want to delete the employees. So I deleted all the employees. That's it. Okay. So let us discuss the update also. Suppose I want to update Sita's salary. So 3,000 to 5,000. I want to give increment to Sita. Then update is a keyword, sir. Update table. These two are the keywords. What is the table name? Employee. Fine. Then what you want to do, sir? You want to set the value. Set salary equal to 5,000. Sir, it will set the value to 5,000. Now the question is, on which basis? Where name equal to Sita. So the same story, suppose there are two employees with name Sita, then for those two employees, the salary will be incremented to 5,000. Maybe increment or decrement. The salary will be updated to 5,000. Right, sir? So that is the next story. Suppose I not specified the condition. I specified only up to here. That means I not given on which basis you want to set the value. Then for all the employees, the salary will become 5,000. That's it. So whenever you want to update, always you need to specify for whom you want to do. So where is more important? For whom it is important. Like for whom in SQL it is where. So these are the DML commands: insert, delete, update. Then coming to DRL. This is select, sir. Sir, generally this is used to select. Instead of select, better to say display. To some of the attributes or all of the attributes. Of some of the records or all of the records. Suppose I want the names of all the employees. So here the story is, what are the attributes you want? What are the attributes you want to display? And for which employees you want the details. So these two we need to specify. DRL is more important with respect to our GATE exam point of view. So this select, the only command we will discuss in the upcoming sections. Okay. Then coming to DCL, data control language. Sir, this is mainly used to control the authority of the data, that is grant, revoke. This is generally used to give permissions and this is to take back permissions. Sir, something like I have a database in which we have so many details. Among this, there is one table employee. On this table, only manager is having access. Only manager is having access. Suppose an employee Sudhakar has joined, who is the manager of our bank. Then I want to give the access to that new manager. Then we use the grant privileges to Sudhakar on so and so table. Suppose he resigned from our bank or he is demoted to something else. Then I want to revoke it. I want to take back. So I want to take back the privileges or permissions to view or to update or to modify the particular relation. Okay. This is the main responsibility of database administrator, sir. We are not going to discuss much about this. Only we are discussing what it means. Grant to give the privileges, revoke to take back the privileges. That's it. Then transaction control language. Sir, this is mainly used to save the transactions or to roll back the transactions. Something like I updated a amount. Something like I updated some amount in savings account. I want to save it. Or suppose I updated some amount wrongly in a particular account. I want to roll back. So these are the commands, sir. Commit, rollback, save point. Sir, commit. In general English, permanently saving. Rollback, In simple English, undo the action. But generally undo the actions. Go to some specified previous stage. Save point. This is the main one, sir. Something like this is the database. I done so many actions. Like suppose I done some 8 actions or 9 actions. Okay. To the same database, I have done so many actions. And I am sure that up to 5, everything is very clear. Up to 5, everything is very clear. So damn sure that no need to change or no need to undo up to here. Everything is fine. And these I am not sure. I am trying or I am making some experiment. Then what I do is save point. Here you can give some names, sir. Suppose for the save point you given some XYZ. Then you are doing that experiments. Here you done some experiments. At that time you thought that the experiment was failed. Whenever the experiment was failed, I want to undo the actions till the previous save point. So undo 6, 7, 8, 9. For this case, we use rollback. So roll back to XYZ. Roll back to XYZ. That's it. This is the main point of rollback and save point. So commit means the data will be saved permanently to the database. Once you've done the commit, all the save points will be vanished. That means whenever you press commit, you cannot undo it. Something like in MS Word document, I can use Ctrl Z. But whenever I click on save, I cannot do undo. So once you done commit, all save points will be vanished. So I cannot roll back. So we cannot use rollback because there is no save point, right? We cannot use rollback. Hope you understood it. So this is the main point of commit, rollback, save point. Okay, let me give one more important point, sir. Whenever you do rollback, the main points, DML actions will be undone. DML actions will be done. All DML actions will be undone, sir. But DDL actions, that is whenever you want to, whenever you created a relation, you created a relation or you changed the structure, they will not be undone. So please remember this point, sir. Whenever you do rollback, only DML actions will be undone, not DDL actions. Then we have already seen everything, sir. Delete, drop, truncate. We have seen the main difference between these, sir. Okay, let me write it like this. Delete, drop, truncate. Right, sir? Sir, it's not like exam point of view, sir. I want to explain very clearly. These two are DDL commands. These two are DDL commands. This is DML command. Then what is the difference? What is the problem? For these two, I cannot use rollback. I cannot use rollback. Am I right, sir? Since those are DDL commands, those actions cannot be undone. I mean, we can use rollback, sir, but the actions cannot be undone. So I think better to write like this. Actions cannot be undone. Okay, better to write like this, sir. That is the first one, sir. The second one, everyone can delete all the records. All the three members can be used to delete all the records. If I use drop, table as well as records will be deleted. If I truncate, data will be deleted. When coming to delete, you can delete either all records or some records. That depends on your requirement. So I have some provision. If you want, you can delete some records. But when coming to some records, it's not possible with the drop. It is not possible with the truncate. These two can be used to delete all the records, not to delete some records. Right, sir? And the next one is drop will delete schema also. Drop, schema will be deleted. Delete or truncate, don't touch the schema. Okay, these are the main differences, sir. Once we apply drop or truncate, those actions cannot be undone. But if you do delete, the action can be undone because of the property of DML and DDL. The second one is all the three can be used to delete all the records, but DML is having a provision that it can delete some particular records also, but the remaining two, they cannot be used. Whenever I use drop, schema also be deleted, but for delete and truncate, schema will not be deleted. Hope you understood it. Right? Let us see one previous question, sir. Just go through the question. Consider the following statements. A foreign key declaration can always be replaced by an equivalent check assertion. So instead of specifying some attribute as a foreign key, can we use check constraint? That is the first one. The next one, given the table R of ABC, where A and B together form the primary key, the following is a valid table definition. So this is one more table in which we are using the table R ABC. We want to verify whether these statements are true or not. Just go through the statements, sir. We discuss it. Let us discuss the first one. A foreign key declaration can always be replaced by equivalent check assertion. So actually for foreign key, the thing is values must present in original table or in parent table. So you may feel that why don't we use check? Why don't we use check to specify the values in so and so list? Okay, something like in our previous example. This is my employee. Here I have some department. And this is our second table, department, in which D name is the primary key. This is the example we have seen, right? Employee ID, so and so details. So now look at this, sir. This is foreign key. Let us assume I have only CSC, ECE, EEE. Then their intention is when you are defining the table, department varchar 2 of some 5, check department in CSC, ECE triple E. This is their intention, sir. So with this, surely the values must present in these three values. So this condition will be satisfied, sir. But the problem is a foreign key not only having only this feature, it is having also the features cascading rollback, cascade. Okay. Unupdate cascade. This is the option. So this cannot be filled with, or this cannot be specified with check constraint. That means you can specify or you can check the values, but this cannot be specified with check constraint. But that means you can verify the values. But suppose CSC deleted from the original table. Can you delete all the values in this employee table, sir? That I need to do manually. So check can replace this condition, but it cannot have this feature cascade. The next one, given a table R ABC. So I have a table R A B C. So they are saying that A and B both are a primary key. So let me write it here, sir. Primary key is combination, right? That means A comma B are prime attributes. A comma B are prime attributes. Fine. Now coming to second table S. A is a integer. So two relations may have same name, but they may not have connection. Okay, something like in student I have name, in employee I have name, in customer I have name. Okay, A, D, E. D is the primary key, they are saying, sir, it's no problem. Now this is the foreign key, sir. Of course, they are using foreign key. So this refers to this table. Okay, but a foreign key must be a primary key in the parent table. Foreign key must be a primary key in parent table. In this case, is it true, sir? No, sir. Here A on its own cannot be a primary key. The combination of A comma B is a primary key. That means if I have like this is a foreign key, then no issue. But I have only one attribute. So it's a prime attribute. It's not a primary key. So that's why this will not be valid. Right, sir? So S1 is false. S2 is false. Hope you understood it. Right? So that is about DDL commands in SQL. In next session, we will discuss data retrieval language, which is more important with respect to our GATE exam point of view. Thank you.